On the 13th of March this year, the inevitable happened. The first case of COVID-19 was confirmed in the country. While the severity of the disease in the country was still uncertain, the world had already been dealt a tough blow as witnessed in some parts of Europe and Asia. While the world's biggest medical manufacturers were struggling to contain the disease, a huge gap in critical medical machinery was left in the system.
A disease which came from nowhere, and God, what has come to the world? Okay, is the world really going to come to an end? And then you find everybody developing ventilators around the world. There's short of ventilators around the world, and that's really what struck me. That why don't we take this up? And also the CS of industry challenging us that if everywhere in the world the automotive industry is developing a ventilator, why can the Kenyan automotive industry not develop a ventilator?
That is how the journey to build Kenya's first ventilator began. The journey of 1,000 miles began with recruiting an able team led by software engineers, hardware engineers, biomedical engineers to actualize the project.
I think there's a lot of talent we have in Kenya, which the local government, the local manufacturers have not really exploded. Youth which come out of university and all that, I think they have a lot of talent. If guided in the right way, they can develop a lot.
My task was, once the team decided on a design, the design process is a whole journey on itself. My task was to now convert that design into electrical drawings on a software, test it on a software, then now convert it to a PCB. A PCB is a printed circuit board. This is what people like to call motherboards and electronic designs. So my work basically was to build these PCBs for the ventilator.
With the motherboard in check, the team thought they were ready to launch and take their ventilator to the market. However, that was not the case. The first prototype was mechanical and could not pass for mass market production. They had to go back to the drawing board.
We ended up looking online and seeing what everyone else in the world is making, and we settled with the design from MIT, the US, and we started developing that prototype. So this is the first prototype, and this was the final prototype we came up with. So this is also a mechanical system which uses an ambu bag to ventilate the patient. So an ambu bag is actually a device that a lot of hospitals already have. And all it does is it mechanically pushes the ambu bag. And this is the prototype we went for. After meeting a lot of doctors and anesthetists as well, we realized there's a lot of downfalls or shortfalls on this ventilator. And we realized there's not a lot of electronic control and patient safety was being compromised here. So we ended up changing the design and going for an electronic control system.
That is how Pomaishi 3.0, an intensive care unit ventilator which can be used on pediatric and adults weighing up to 180 kgs was born. The ventilator has since gotten the nod of approval from the Kenya Bureau of Standards.
Firstly, we've used battery power, which is a solar battery. This enables us to use this in remote places as long as you have a couple of panels and you're good to go. The other thing about this is it's a portable unit. So as long as you have portable oxygen cylinders, the system will be able to be used in ambulances, in airplanes, in any patient that is required for ventilation for a short period before they move to the ICU or being transported from upcountry.
However, despite the victory, caution is always the order of the day due to the critical nature of ventilators.
There's a hospital that burned because of a prototype, or let me say a new model of a ventilator that was built. It was a response, a COVID response ventilator, and that burned because of it burnt a whole hospital because of a spark that triggered oxygen. We are working with oxygen here, which is it's combustible.
Despite the risk, John Latham says the benefit outweighs the risk as Pomaishi 3.0 is over 3 times cheaper than the globally imported ventilators.
A lot of these international companies have been creating more and more expensive machines. Yeah? And this machine here, we're looking at a cost point of around $10,000, £1,000,000 compared to a typical ventilator is priced around $30,000, $40,000, even $50,000.
Furthermore, Latham acknowledges that COVID-19 has reiterated the place and importance of medical technology.
You're essentially hiring the medical equipment when you use it. That's part of your bill, is the ventilator or the X-ray machine or whatever you're using. And you can see the numbers here. We're looking at 4-fold, 5-fold, 6-fold reduction in price, which should impact bills equally over time as these machines get into the market.
With cases of COVID-19 on the rise in the country and the rest of the world facing a severe second wave of infection, machinery such as ventilators will be key to a quicker recovery. Latham urges that the government in its capacity has to support local enterprises, particularly those currently in the space of manufacturing personal protective equipment in the fight of COVID-19 pandemic.
If you look at a lot of countries, when you see very nascent early stage startups like this, there would be grant money available, there would be tax breaks, tax concessions, tax waivers, and I think also when products get to market, when we do all this work to get them to market, we should protect our industries. Other countries do it, and we should do it too.
With every breath in, you buy Kenya, and with every breath out, you build Kenya. As efficient as the global ventilators, but 3 times to 5 times cheaper. NJA Technologies has revolutionized local manufacturing in the country. For Metropole TV, my name is Ndero Oganga.